Hello, it's day 68 of the Liberator project, and filming today in my car, which is pretty apparent is still full of lots of junk. Well, actually, it's not junk because the junk's been taken to the dump. These are spurious car parts that will either get used on the kit car or be sold in their own right. But I didn't see any point of taking them out of the car because, you know, I still need to do things on the both the kit car and the silver Mondeo. So they're sort of sat there and my car's a mess. When that's done, I'll start emptying my car out. I might convert the Mondeo to be a camper. I've done that before, and it's very nice to have a ability to stay in your car if you're well, especially with my health, if I'm away from home and not feeling good, to be able to pull in somewhere and just sleep for a couple of hours, and it is useful. And I've still got it sounds daft, but I've got all my conversion stuff I did on my first Mondeo, so I can actually put a microwave and a sink in here as well as a bed. But anyway, that sounds ridiculous, but later on in the project might happen. Right, well, the forecast was right. I mean, it's drizzling, or it's been horrible all day. When I looked up this morning, it said there was a 67% chance of rain, and that's certainly come true. Wednesday's looking better. It looks like it's only got a 10 or 20% chance of rain, so with a bit of luck I can get back to Chelmsford then and actually sort the cars out, because I'm apparently ready to go. The fuel pump has got something that concerns me in the Hayes manual. It says you can take it off using normal tools, but to replace it you need a special tool. Well, I'm not going to buy a special tool to change a fuel pump of a car that can put up for sale for a trivial amount of money. So I'm sure I will find some way of getting that back together, with the use of mole grips and clamps and bits of wood and block and tackle and a Swiss Army knife. We'll get the fuel pump back in somehow. So I'm gonna have to improvise on that when I get there, but I need a nice day to do that. First of all, I haven't got the car running because it will make a noise. I thought it was nice if it's just the two of us in silence, but also it means everything's going to steam up, and well, I don't think that's important. It's much better if you can hear me properly. But last night, after I spoke to Ash, I went to see Sylvia and ended up having a chat. What happened was we got into this conversation somewhere about my relationships, and I'm quite adamant, what I don't want. So she goes, "Oh well, I'll take a list of a few things." So I was like, "No trouble at all, just a couple of bullet points." Well, there's pages and pages of it. So yes, I have. It's quite nice. She insists on writing everything down. So there's a lot of things there. So if I do it, well, I'm bound to. If I've got a quiet day and I do a video about, what I'm looking for in a partner, it's great. I mean, I've got enough script going on here for a couple of hours. In fact, I'll have to cut that down to make it a decent length, otherwise it'll get stupid. And also, you can understand why this is getting to be pretty much a null set of partners, and which is why I'm quite happy being alone at the moment, because there are some scary people out there, and speaking as a single person, there are some scary single people out there. Okay, we'll do that another day. Today I was doing eBay and I sort of screwed up a bit, really, because I find it incredibly boring going through things and photographing the listing when I haven't done it anywhere near enough than I should do. I mean, I really need to get back onto that this evening. And the reason was, I'm going sailing. So, I was I got distracted basically looking at other things that are related to sailing. Now, what's important, when you're going sailing? Yeah, what's one of the most important things? Right? Yes, you're right. It's to get a tattoo. So I've been looking at tattoo designs. I've decided that if I'm going to be, sailing the world and be a sailor, I need at least one tattoo on my arm here. I'm going to get something, and maybe a complementary tattoo on the other side, maybe sort of red and green. Obviously the boats have got pilot lights in red and green. But we'll see. But decided that yes, tattoo is something that I need in the project, and I've got a ridiculously high pain threshold from everything I've been through, so I don't think that's going to be an issue for me to get one. I mean, I remember a friend once said, oh, you'll think you're good at handling pain. So I just held his cigarette against my arm to say, yes, I do have a very high pain threshold. And, it's probably due to all the nerve damage and stuff I had when I was in hospital. But yeah, I don't think getting a tattoo is going to be an issue for me at all. So that's I'll post some designs up actually on my Facebook page when I've later on in the project. Before I'm going to do it, I'll certainly post some pictures up, and then you're entitled to give your feedback before I go ahead with it, before I get permanently scarred. But anyway, that's something I got distracted with today. I found it absolutely fascinating to look at tattooing techniques and what people can do. I started to watch a show called Ink Master to see the different styles, and yes, I got totally distracted with that because it was really interesting and creative, rather than do eBay, which is really tedious. So that's one of my problems, is being a creative person. I get drawn into creative stuff. But anyway, that's pretty much the end of today's video. Again, it's a short video. I didn't achieve very much, and when I'm ready for a tattoo, I'll post up possible designs for your feedback. Right, so as I said, right, when I've got quiet days, I'll do a bit of background information about myself. So if you're just following the Liberator project, thanks very much. That's the end of today's video. And if you're interested, and I can understand if you're not, but if you are interested, I'm going to talk for another, well, knowing me, probably 10 minutes about my career. So if you're interested in that, stick around. If not, I appreciate your support, and I'll see you tomorrow. Right, something that it's day 68. So my favorite assembler language is a 68,000. So there's a very tenuous connection there, but I'm going to play on that because it links to the next section. Right, once I graduated, and it's really weird because I always wanted to sort of design and build things. Like when I watched Star Trek, I always really liked Scotty, because he could actually make and build things and get things working. And that was, that to me, that was more important than Captain Kirk, actually giving orders. It was like, yeah, well, actually fix the warp drive. That's the important thing. Understand the technology, fix that spaceship. So that was always my interest. And I've always been very artistic, and I'll get into that another day. But and career-wise, I always wanted to design and build things, make things better, improve the world, improve products, and also the technical achievement of things. It's really important for me to understand things and have a sort of, at least a working knowledge of everything around me. Even if I don't understand the fine details. The great thing about having the internet is if you don't know something, if you've got the basics and the fundamentals of science in your head, seriously, you can look things up and you can get into it as far as you want. Even actually finding PhD research papers, and although they might be very challenging for you, you can go through it a bit of a time and understand it. Certainly you can get the gist of it, and then you can go into it as far as you want. It depends. It's not a case of being scared of things. You can find anything you want nowadays. It's just a matter of how much time and effort you're willing to invest in doing that. So that's always been a great interest in me. Right, but anyway, my career. Once I graduated, I got a job as a design engineer. I was doing industrial robots, and I was naive, and I didn't realise how much these things scared me, because I could appreciate how terrifying they are. So I was working at 300 volts DC at sort of 30 amps or 100 amps, and if you touch something like that, it will just burn your hand off. In fact, it will probably kill you and burn your arm off and incinerate your corpse. It's terrifying amounts of power, and I really hated that because I I can see the danger. And if you're designing something, or if something's broken and you're fixing it, by definition there's a fault with it, and it's dangerous. So I started to, I had this plastic perspex rod, and I didn't like powering up the high power circuits. I realised very soon that wasn't for me. I mean, I've seen in the production of this company I worked for, they used, this is going back a while, they didn't have the high power FETs they have nowadays. They had these TO3 cases, which is metal boxes that hold the transistor, and they used for sort of dissipating the heat. And to get the power up on a 3-phase system, there was 30 or 40 of these things, and they had something called a cascade error. So if any one of those broke, it would take out, all the current would flow through that. Then it would take out the next part of the limb, then the next part. So it would cascade and take out pretty much the entire circuit. And when these things went, I mean, you're putting all that energy into a tiny little, you know, a bit of silicon, which used to vaporize immediately, and they used to literally explode. They'd blow the metal caps off. So when something went wrong, it would be like a firecracker or a machine gun going off, and there'd be metal caps flying all over the production line. Nowadays, I assume there'd be some sort of shielding, but it was awful. So I've realised that was not the job for me, and big mistake. So I got more into the lower analog electronics, and more precision measurement and control, and also microprocessor control. I mean, I like working at voltages less than 30 volts, because certainly if you get below 12 volts, you're safe. You can probably even lick that. I mean, it would hurt, but it won't kill you. So I went down onto lower voltage rather than high energy circuits. I've done both, but you know, I do see an element of danger in things. So after that, I went to a company that did 3 computer systems working in parallel to do safety systems for all platforms, and that was quite interesting. But I went there and I just did software. I didn't do electronics anymore. I got into the sort of I did a tiny bit of electronic design, but mainly I got into writing the software for these control systems. And there's one engineer in particular. His name's Kevin, who has been an amazing influence on my career, my style as an engineer. I really liked the way he wrote software, and he was good enough to spend like a whole afternoon go with me and explaining why he did things, and you know, like the indentations and the comments and the way he worked. And it was just so logical and straightforward and easy that I've never forgotten that afternoon. And I write, even when I had my own business, I write my software in exactly, you know, Kevin's style, because I think logically it's the best style to work in. It's very, very precise. Now, people know me, I'm extremely dyslexic. I have a lot of trouble distinguishing B's and G's and D's and P's and Q's and N's and U's and S's and Z's. I really have, you know, that's been a problem. That wasn't picked up when I was at school, because back in the day, no one really knew what dyslexia was. And it wasn't even picked up during my degree, which was a shame, because I've got extra bonus points for having it. And it was only picked up later in life, when I went to one company and they did these tests, and they said, do you realise you're very badly dyslexic? And that explains a lot. So from them, I've seen my own doctor about it, and I've sort of inadvertently developed lots of coping mechanisms, which is why it wasn't picked up. But as a result, all right, of that, I have to work very structured. I work with software. I'm very careful with the names and, you know, the way things are labeled and the comments. Just because if I start going you know, random, like a lot of software engineers do, and they do whatever they want, it becomes very hard for me to keep track of things. So I do have to do that. The plus side of dyslexia is that I see things in very much like I find it hard to distinguish an object, because a lot of letters are the same object, they're just rotated or flipped around. So having that sort of sense of sort of 3D awareness means I'm very good at a lot of things, like design, because I don't get stuck. I don't get stuck doing it one way. I can flip things over, and I just see things in different angles. So to me, it's like I just look at some designs and go, oh, just do that, mirror it, flip it over. And you know, it's, you know, everyone's got their own skills and pros and cons, and I'm glad I'm dyslexic, because for me as a designer, the benefits of it, you know, outweigh the problems, because I can still read and write, albeit slower than perhaps I would otherwise. But you know, I can cope, and it does mean I've got the edge when it comes to doing design work, which, as I want to be a designer, is more important. It's, you know, it's very useful for doing art and design. So you know, I'm glad I'm like that. So anyway, once I'd done the software, I worked for a company doing image processing work, like digital frame stores and image processing. And you know, this was still very crude back then, and you couldn't do it with PCs. You had to have racks and racks of specialist equipment. So you know, you had to have high-speed memory, which is laughably slow these days, but at the time it was, you know, this was cutting edge speed. and it's very expensive. You had racks of memory loading up images and multi-leafing memory buses, but you had to have specialist hardware equipment. So I did an awful lot of very, very high-tech digital design at that point, high-speed digital design, and also high-speed analog work to actually digitize the video signals and recreate the video, because basically the monitor connected up via an analog signal and video cameras were analog signals out. So I did that, and that was when I was doing my my MSc in medical electronics, which was image processing. And I also, when I set my own business up, when the company I was working for was going under, I set my own business up doing this image processing work. And what I did was I went down to the Science Museum, and I spent literally days in the Science Museum in the computing section looking what other people had done and trying to understand it, because my maths, I'm good at maths, but obviously I'm not good enough to come up with new stuff. I'm not a mathematician, but I'm good enough to understand how other people have worked and how their schemes work. So I spent a lot of time going around to all the different processing and computing sections and making sure I understood every one of them. And even though it turned out to have some problems, but I even did like the difference engine and the analytical engine from Babbage, going way back, and looking also at mathematical techniques people had used. And some of them were really fascinating. Like there was a weather system that did an inverse Fourier transform, and it used on these glass domes that use resonance. So you actually, it is a way of creating a harmonic sequence. Very clever. I spent a lot of time understanding Fourier analysis from first principles, so I could do that. And this is being dyslexic. It was really weird because I could actually see Fourier transforms of images. So the professors were totally freaked out by this because they could give me an image and I could sketch out what the Fourier transform of it was, which is something they didn't expect to happen. But that's just the way I work. I work very visual. And once I knew the scheme, I was really, really good at that. However, when it came to doing other transforms like natural logarithmic transforms and Z-plane transforms, because there's no direct image, I was terrible at those. It was like, if you give me a way of seeing it, I can see it. I don't even have to think, I can just see the answer. Whereas if I haven't got that process, then I've got to chug through it like everyone else. And because I'm not used to chugging through things, I'm actually worse than everyone else, because I've got to actually do it properly rather than just write the answer down. So I went through a lot of the Science Museum looking for tricks, and one was very good. It's called Russian multiplication. Now, if I can find a link to it down below, but it really suited microprocessors at the time because they didn't have onboard hardware multiplication. You had to do it all by adding and shifting, and Russian multiplication was superb. So I wrote my own mathematical algorithms using that technique, and it was so much faster. I mean, it really did improve the system. And when you're processing an image, you're doing sort of a matrix convolver or something on it. Every time you save one microprocessor instruction, by the time you multiply that over several million times over the image, that makes a real difference between having like a real-time video and having a very it's almost like stop frame motion. So I spent a lot of time optimizing things, and it was very impressive. I mean, I went to companies say you couldn't possibly do this with just 168,000 working on this, and I'm going, yes I have, and I would actually demonstrate and prove it. And but that was all due to very, very low level optimization. And again, I went through with Newton and Leibniz, I went through calculus from first principles and derived that. So I was really really flying with image processing. And I did say a lot of design work. I mean, one year I did 7 designs. Now typically a design, because a small company, I was very flexible and I had some help, but in a small company you can work really fast, whereas big companies would typically do one project in like 2 years. I did 7 in 1 year, and yeah, it was very good. But with these things you get something called burnout, and I really felt I burnt myself out in that time. I wasn't sleeping enough. I was just working continually, and I didn't have much of a social life at that point. I was just purely focused on the business and image processing work, which is what you have to do in a company to set it up and to get it successful. And it really did burn me out. And the other thing that happened was that PCs got so good, and it's very hard for me to sell a piece of equipment that's like £27,000 to do some image processing, when someone can buy a PC for you know, at the time about £2,000, which would do a lot, and it was just about the software. It wasn't really about the hardware anymore. So that my company shifted, and we moved from doing image processing work to doing any sort of design work. So I designed, well, I designed the intercom system that went in black cabs, you know, a little switchable stereo amp, things like that, very low tech. And it was very hard because I'm an engineer, I'm not a salesman. So if someone says, how much is this going to cost, and I have a figure in my head, you know, and then immediately when you go to sell it, they go, can you do anything on the price? And because I'm an agreeable person, and because technically I can see things are not difficult technically, you know, I would sort of try and do something. And a big disaster, because the electronic design of something like a little intercom system, the circuit I could knock out in an afternoon on the back of a beer mat off the top of my head. It's really nothing to it. But the doing the paperwork, doing the circuit layout, getting the boards manufacturers, doing the corrections to the, you know, because the customer invariably wants things changed mechanically to fit in with their system. And by the time you do that, the electronic design is actually probably only like 10% of the work. A lot of the work is in supplementary stuff. So making a product from a design is a serious undertaking. So, you know, so I did a couple of jobs that lost money because I had underestimated the administration that goes with it. And you know, then I started to charge prices that I really needed, you know, which any design bureau needs to charge to make a living. And people were, you know, basically saying, oh, it's far too expensive, we can't afford that. And undoubtedly they're going to end up paying that, unless you can find someone that's willing to work from their garage for hobbyist rates. As a professional company, you know, you do need to charge all these extra £1,000. And people would argue, they said, well, you can do that design in an afternoon. And I'm like, yes, I can. I could do it in a couple of hours. But that's only 10% of the work. And people who didn't know about design bureaus would, you know, sort of bait me down on price, and it was horrible. I mean, I ended up doing jobs that made a loss, or I ended up, you know, having to go back to companies to correct something that wasn't my mistake, but I had to prove that it wasn't my mistake, and it was just time and money everywhere. So the thing that clinched it for me, which is why I gave up having a design bureau, I designed a system that decoded radar images for an RAF base, and it was really nice. It converted the radar signals into television pictures, and then it compressed them, and you can actually squirt the images. You can allocate them and actually transmit them around the base so other people could see them in different, you know, so if you had the generals are in a meeting, they could actually get the picture from the radar system, whether it was real time or stored, and actually convert that to an image and display. And so it was a very, very nice system. And you know, it was that was good. Then I made, which is the biggest mistake I ever made in business, right? So it's all agreed, it's all working, all the technical side of the radar images is working fine, and I've matched all the colors perfectly, you know, because within sort of 16 million resolution to the colors of their system. And then this is where I went wrong. One guy said, can we change the colors? Now, as an engineer, yes, of course, just tell me what colours you want and I'll dial them in, and the software can remap the colours in your system onto what you want displayed. Oh, I was so stupid. It took 18 months of meetings to agree the damn colours. And I went back to this company and they wouldn't pay me until the job was finished. I didn't get paid for the last, I mean, it was only the last payment, but it was, you know, it was still quite a considerable amount of money. It was still a six-figure amount. Sorry, a five-figure amount. And you know, that was the last stage payment of this. And I'd go to meetings and these people didn't know anything about image processing, but they knew what colour orange they liked. Now, if you display orange on different monitors, it looks like different colours. So not only have you got, everyone has got a different damn opinion, you've got different monitors, and it just went on and on. It dragged on for 18 months after the project finished, trying to get them to agree colours. Now, if I'd have just said, no, the colours are fixed, they're the same as your system, they would have had to agree that, or we could have made a second contract for, you know, another 20 grand, and I would have remapped the colours. But because I was an engineer rather than a salesman, I just said, yes, pick what colours do you want. And that basically, by the time they did decide the colours and I got paid, I'd been up to New Oxford and back about 30 times. It was there was no profit. In fact, because I had to borrow money from my business to get everything made, and they'd only paid stage payments, and I really needed the last one. It was distraction. I couldn't do other jobs because I kept going back and I kept phoning them, and it wasted months of my time in total, and I didn't get paid for any of that. And eventually I did get paid, but basically the people that worked for me are still getting paid. I was getting more and more in debt, and it ended up I'd worked like stink for 2 years and I'd earned pretty much nothing from it. So I decided that the design bureau couldn't charge enough to make it viable. And I'm a designer. I'm not into negotiating contracts and chasing people for money. I hate that sort of thing. I like designing. So I decided that being a contractor was a much better idea, because I get paid per hour, and I'm paid per hour to do designing, and I pay for an accountant or an umbrella organisation to handle the paperwork. I can get on with what I'm good at and what I like doing. So I've been a contractor most of my career now. I have done a few permanent jobs. I mean, I was a contractor at a company, I won't give the names out, but it was a company doing military telecommunications, and I really liked it there. And the manager really trusted what I was telling him, because I didn't bluff him. I just told him straight what was possible and what wasn't, and my estimates were very good. And I didn't try and spin it politically. I just told him straight what could be done and what couldn't. So he trusted me, and I went there as a permanent employee, and it was great. I was in charge of a team of people doing sort of R&D work. And what would happen is someone like the salesman or a customer would come up to the company, and they'd have a new requirement, and they'd ask me if it could be done, and I'd go and investigate it. And if it could be done, it might go further, and they want the prototype built or something. Now, I insisted everything was done in line with company design rules anyway, even though we're knocking up a demonstration unit. And a couple of things I did actually went pretty much straight into production when I finished, because they'd finished the design and then they're going, now can we get this into production? And I'm like, yes, here's the information, you can basically build it, or very, very little effort to make it a production unit. So I loved that job, and I was, I probably would have stayed there doing that. And I liked having people to do a lot of the basic work, and I could do the system architecture and the designing. But I got very ill. I mean, my health was terrible, and I couldn't work. I mean, it became very difficult for me. I mean, I took a lot of time off, and I was on sick pay, but that's not enough. And they were good, but after a while it was a bit, like they needed me to be working. They needed me to get things designed, and I just too ill. So it we sort of lingered on and off for a while, me being in hospital, and they did keep my job open for a time, but after a while it was ridiculous. I mean, I had one time I spent months in hospital, and I couldn't work. I mean, I could, when I was having my treatment, I mean, I couldn't do anything. I was basically throwing up it was like I was seasick for a month at a time. Now that might come back to haunt me, that phrase, but that's what it was like when I was in hospital. So I have practiced on this. Right. Oh, God, I said I would, if you know me, I mean, I can talk for as long as you want. I'm so people interested in my career, well, okay, I will talk, and there's no reason to watch all the video. If you've had enough, turn it off and come back tomorrow, and I'll get back to the project. But I'll carry on for now. I've really finished what I've been doing. I've done loads of different contracts. I mean, I had one contract which was very, I mean, I'm SC security cleared, so I can work on top secret military products, because I was and research, because I was doing military telecommunications. And then I got a job doing, this was great, it was looking at future technologies that could be used for missile and defense systems. So I met research groups and customers that were doing cutting edge work what could be done with, well, I won't go into too much, but polymer coatings that actually incorporated waveguides, all sorts of clever stuff, that they were trying to make things invisible. Not invisible, I mean invisible from a radar perspective, not, you could still see it sat on the bench. But yeah, it was very interesting. So I spent a while doing all these new technologies and learning what was the cutting edge and what was available. So it was very useful and very interesting. So I really enjoyed that contract. I've done loads. I mean, I literally must have done, I have so many projects, I lose track. I mean, I designed an autonomous robot that went into oil pipes and it crawled around the oil pipes, and they could use that for videoing the inside of the welds to make sure that the pipes weren't leaking. And the idea was that, when the robot got stuck, it could back itself out and come back to the surface, so you didn't need to tether it. So I did prototypes of that and did designs and did quite intelligent software that could work on those sort of things. And what else have I done? Last year I was working on endoscopes, basically things that get stuffed up people's backsides. So I was looking at that system. Again, it was video, but I was mainly concerned on the control of pumps. So what happens is, if you've got some, this is a pretty horrible job really, but it was quite amusing. It tied in my medical background with my electronic design. And what you do, someone had a polyp or a cancer, they had different tools in their disposal, and the system I was working on was looking at, you could inject a polyp or a tumour and it would inflate it with saline, and then they could cut it off and separate the tumour from the intestinal wall. So I was looking at doing different ways of doing the pumping system for that. And you have to be very careful with that, because if you start injecting water into people at too much pressure, you can kill someone. So you had very, very fine motor control of the pumping mechanism. Or sometimes you need to use the same system in a different mode, where you could flush out someone's intestine to have a look at what was up there, bum. It's not, it's not always glamorous. The start of this year, well, I've worked in Bournemouth for a while. I finished in January, but I was doing electronics and software there. And this was a system where it uses ground transmission of high current pulses to broadcast a signal from the bottom of an oil platform, a drilling head, to broadcast to the surface. And that is extraordinarily difficult, because this thing could be like, a couple of kilometers down at the bottom of the seabed. So how are you going to broadcast a signal all the way back to the surface? So I was looking at that, and looking at the hardware side, the control side of it, to make sure you had enough signal to broadcast, and then the software that was encapsulating. Well, the signals were encapsulated, but it was a way of encoding the data using what could be transmitted, and then recovering the signal from the transmissions. So that was very interesting. I mean, I did a lot of maths, a lot of technical stuff on the actual transmission schemes, and then I implemented some electronics, and then I wrote a lot of software. So I was very involved in that project. I did enjoy it. And I wrote sort of bare metal, I didn't design the processor boards, but I wrote the software that sat on the processor boards, which actually controlled things. And that was very nice. I enjoyed that job, and it was all very modular. Again, writing in my dyslexic way to make sure it was perfectly legible. And it could just, it could be, once you built the modules, they could be built into different systems. So, but I enjoyed doing that. So that's all my sort of electronic design and background. I mean, I don't just do the electronics or the software, I do production engineering. So I will take something like a food mixer, and I can redesign that to be cheaper to manufacture, or add additional function into it, where they want an LCD screen to control it. So that's part of, I suppose you wouldn't really call that so much design, it's more ergonomics. It's how the interfaces work with the user. Production engineering is how to make the same thing, but make it easier to manufacture, to make it cheaper. So you give it the same functionality, but you just cheaper, save money, make it cheaper to manufacture. So that's the sort of production engineering side of that. I've done both those. And I had one job, I worked for a company that did weighing machines, and because they liked me, I've been very versatile and I've been very helpful. The guy didn't want to lose me before they started the next project. So he said, you do oil paintings, you're an artist. I said, well, I can paint a bit. He goes, right, we've got this job. And what they wanted me to do was look at these weighing machines, the ones that gets used in sort of Sainsbury's and Tesco's. You put your bananas on and they weigh them and print a label. They made those. And they wanted me to look at different colour schemes and different types of scales to improve the look of them. So that was very nice. I had the opportunity to make, you know, we all know that the scales are always going to be that computer sort of beigey grey colour. There's not a cat's chance in hell of them making more interesting than that. But they gave me a budget, and I went away and I made some in, you know, red, green, blue, different types of that, and a white one, and different patterns and different, you know, textures. And I made a range of scales for the sales team to look at and see what they could sell. And being me, I made a black one with chrome fittings. Oh, that looks so good, but obviously it's never going to be used. But you know, it looked cracking, and I'd have loved to have done a steampunk one, but you know, it was a pointless exercise in my opinion, because then the sales team are always going to sell grey scales. I mean, if you look in any of the supermarkets, they're all grey. They're expected to be grey. It doesn't show the dirt, and it doesn't distract people from anything. And if you've got like a, you know, a bright blue scale and it's next to some fruit, it might make the fruit look, you know, not ripe. It might, the colours might clash. So you're never going to pick a coloured one. But it was quite nice having the budget, so I could actually do some artistic design rather than just doing electronic design. So that was fun. I wouldn't want to do that for a living, permanently for a living. I wouldn't mind doing it for, you know, 6 months. But that was sort of, you know, that was an interesting part of it. So anyway, that's my career. I do, you know, electronic design, software, anything in between. And I do production engineering, and I do ergonomics. And if pushed, I can do a bit of artistic designing as well. That's my engineering part of my career. Something I do for fun, and I've been doing more and more, is I do acting. I do acting in films. Now I've, you know, I've been in, last year I was in 11 productions. Some were student productions, some were corporate videos, some were just really, really bad. They were sort of, you know, a demonstration of something that, you know, I know was never going to be the final actor in the thing. They just wanted to sort of show a pilot. So, but that was quite fun. I don't get paid very much for that, and I get paid probably between 5 and 10 times less than I get for engineering. But I love doing it. I mean, I'm quite an extrovert. I can talk, you know, I can improvise for as long as anyone wants. I mean, I can talk for half an hour here. I could talk for 2 hours if need be. I've got no fear about public speaking or getting front and acting. So again, I try and be as useful as I can on the film set. And from different parts I've had, the directors have actually used me in other things as well, because, you know, you go along without an ego. You just go, what would you like me to do? And I tell you, I'll try my best to do it. You know, if I don't do it well, okay, you know, I'm not the world's greatest actor, but I'll give it a go. If you want something else, I'll give that a try. So that sort of helpful attitude goes a long way, I think, far more than my ability to be an amazing actor. But I love doing that, and it doesn't pay very well, but I say it's fantastically enjoyable. I've met a lot of people. I mean, something that was wonderful once, I was filming down in Camden, and this sounds horrible, but the camera or the lighting had broken, so we couldn't film. So the director gave someone a company credit card and put us in a bar and paid the guy to keep the bar open till like the small hours, and just basically told to entertain ourselves. Now that was superb, because imagine a bar packed with actors and entertainers and singers, and it became like a bit of a showtime, and that was fantastic. I had a lot of fun there. You know, I think we ended up sort of dancing and doing grease and just generally having a lot of fun, and I was paid for it. So that was one of the most enjoyable things. But I've been, you know, I'm usually a bystander in the background. I've been in a couple of science fiction films. I don't usually have to talk. So though I have done, I mean, I've improvised parts. There was in one film I had to have an argument with my girlfriend. They found me this black woman who was my girlfriend. I don't know why I always get you always sort of see me with a black woman as a girlfriend. I've had that in a few films. And then we had to improvise an argument in the background scene, and of course I was quite fired up about Arlene, so I really laid into this poor girl. And the director goes, you haven't got to be quite so well, tell me what you want. But it was it was amazing. I could keep going for as long as they wanted, and I could do the same thing over and over again. You know, it's like, okay, we start the argument from the start. Another thing, I was in a film as a mourner in a funeral, and I can make myself cry, you know, if I need to on film. It just takes me about, you know, half an hour to get myself into the right mood. I can cry on demand. And oh God, it was there for 5 hours by the graveside or in the church crying, and no one can cry for 5 hours. You know, I didn't do that when my granddad died. So the makeup lady, you know, between scenes, they had to run around with this little squirty dropper thing and squirt everyone's eyes as they, before the, you know, between takes, and they squirt stuff into your eyes to make it look like you're still crying. But that was actually hard work, because it wasn't, that was a day of pretty much, you know, 5 hours on set filming with just a lunch break, whereas some of the acting work I did is, you know, is literally 5 or 10 minutes, and you spend the day, you know, eating, drinking and chatting to people. So anyway, right, 14 minutes. I said I could just talk. So I hope you found that interesting. But if not, you know, you haven't got to, there's no reason why you got to stay to the end of this. You know, just when you're bored, turn off. And I told you I can talk for as long as you want. So